All right, let's look at the homework of 14.8, problem number 2. All right, so let's look at part 1. All right, so we need to optimize this function f of x comma y with the constraint xy equals 1. All right, so if you take the gradient of f, you're going to get 16x comma 16y. All right, so just a partial with respect to y. Right here, so partial xy with respect to x is going to be just y. Partial derivative of xy with respect to y is just going to be x, right? So let's submit. All right, I came back and looks like we got the part 1 correctly. All right, so let's look at the part 2. All right, so we set the gradient of f and lambda times gradient of g equal to each other. And we have equation 16x equals lambda y, 61 equals lambda x. All right, first equation we have, so we just have to do solving for lambda. So you have a 16x divided by y, right? All right, so just divide both sides. And substituting lambda value into the other equation, you're going to get, let's see. So we're going to get 16. Oh, I have to do some work. Hold on a sec. All right, so we're going to plug this guy right into the equation here. So we have lambda there, right? So this is going to give us 16y is equal to, right, 16x over y and multiplying by x, right? So we can divide both sides through by 16, like that, right? Then multiply both sides by y. So we get, so multiply by y, you get y squared is actually equal to x squared, right? So that's probably what they're looking for. So I'm going to put the x squares there. All right, we can, let's see, so I'm going to just type it in, all right? So here we got x squared there, right? So if you take the square root of both sides, so plus or minus x. All right, so submit for testing. All right, I came back and looks like we got the part 2 correctly. All right, so let's look at the part 3. All right, using xy equals 1 and x squared is equal to y squared equals x squared, we get the possible extreme points. All right, so let's do some computation. All right, so let's do part 3 here. So when you have xy equals 1, so let's do y equals negative x, and also separate case y equals x. All right, so if you plug y equals negative x into this equation right here, right? So x times y, but the y is negative x. So you're going to get negative x squared is equal to 1, right? But this guy has no real solution, because then you would have to get x squared is equal to negative 1, right? There's no real number to satisfy that, because if you square it, it's always going to be a non-negative number, right? So we don't get anything from there. So let's do the other case, y equals x, right? So if you plug this into here, just like before, we get x squared is equal to y. So this is going to give us x is equal to plus or minus x, plus or minus 1. All right, so let's type it in. All right, so we get, let's see, when x equals 1, so x equals y, right? So it's going to be 1. And when x is negative 1, y is also negative 1. All right, so let's check the answer. All right, I came back and looks like we got the part 3 correctly. All right, let's look at part 4. And we want to evaluate f of 1, 1. And what was the f? f is the 8x squared plus 8y squared. So if you plug in 1 and 1, so it's 8 plus 8, so that would be 16, right? And if you put the -1 and the -1, but x and y both get squared, it really doesn't make any difference. So it's going to give you 16 as well, right? So let's submit for testing. Alright, I came back and looks like we got part 4 correctly. So let's look at the part 5. To decide whether at this point f is a minimal or maximal, we can check the value of f at other points on the constraint curve xy equals 1. So when x equals 2, so y is going to be 1/2, right? So you just have to solve for y, so you get 1/2. And we have, let's see, x, so if you plug in 1, x equals 2, and put 1/2. So what was there? So 8 times 2 squared, so 2 squared is 4, and so 8 times 4 is 32, and plus 8 times, let's see, 1/2 squared is 1/4, so 1/4 times 8 would be 2. So 32 plus 2, so that's 34. Alright, 34, which is greater than, or larger than 16, so which makes 16 probably the minimal value, but let's check the answer. Alright, I came back and looks like we got for part 5 correctly. Alright, so last part. Alright, therefore at point 1, 1 and -1, actually 1, this should have been -1, but we're going to have a minimal value. And therefore we conclude that, let's see, maximum minimum value. So there is no maximum value. So I guess I have to say does not exist. And the minimum value is 16. All right, let's check the answer. All right, I didn't read the question. Instead of does not exist, we have to put the n none. None, right? So let's check again. Alright, it came back. It looks like we got the last part correctly. Alright, that's it. I hope that this was clear.